In this video, it is the continuation of the rank of the matrix part 2. In this video, we discuss about the how to find out the rank of the matrix by the echelon form. The outlines of this video is the echelon form, rank of a matrix by echelon form, problem and grade problem. Echelon form, any matrix is said to be in echelon form if it has following property. The first non-zero element in a row should be unity if possible. Second property is number of zeros in a rows must be in monotonically increasing order. And the third property is that zero rows must be in the bottom. Let us consider the echelon form by the example. The first example is here. The first non-zero element in a first row, it is unity. In the second row, the first non-zero element is unity. And in the third row, the first non-zero element is unity. So the first condition of the echelon form is satisfied. In the second row, we have the 1 0. In the third row, we have the 2 0. So we have the 0 are in the increasing order, that is the monotonically increasing order, and the second condition is satisfied. But here we have the non-zero rows because we have the non-zero element in this rows. Again, we have this is the non-zero rows because we have the three non-zero element. Again, this is a non-zero rows. So the third condition is not satisfied. What is the third condition? The third condition is if the matrix is having the zero rows. What is the meaning of zero rows? Zero rows is the rows which contains all the entries are zero is called the zero rows, which lies in the bottom of the matrix. So here we have no zero rows. So it is a echelon form. Next example, again, the first non-zero element in a first row is 1, that is the unity. In the second row, the first non-zero element is 1, that is the unity. And the third row, we have the first non-zero element, that is the unity. So the first condition is satisfied. In the second row, we have the 1 0. In the third row, we have the 3 zeros. And in the fourth row, we have the 6 zeros. So the zeros are in the increasing order. That is the second property of the echelon form is satisfied. In the third property, this is the zero rows because all the entries are zero. And the fourth row, so this is called the zero rows. This is called the zero rows and which is lies in the bottom. So it is a echelon form which satisfy all the properties of the echelon form. Now the one more example is here. Here the first non-zero element is 1. The first non-zero element of the R2 is 1 and the first non-zero element of R3 is 1. So the first condition is satisfied. The first 1 0 in the second row having the 2 zeros, in the third row we having the 3 zeros, and the fourth row having the 6 zeros. So all the zeros are in the increasing order. So the second property of the echelon form is satisfied, and the zero rows lies in the bottom of the matrix. This matrix, this row is called the zero rows. Hence, it is a echelon form. Now move to the how to find out the rank of the matrix by the echelon form. The rank of a matrix in echelon form is equal to the number of non-zero rows. The number of non-zero rows of a matrix gives the rank of the matrix. To understand how to find out the rank of the matrix, let us take the one example. Find the rank of the following matrix by reducing it to echelon form. So we converted this matrix into the echelon form by using the elementary transformation. Here we use the elementary row transformation. R2 replaced by R2 minus 3R1 and R3 replaced by R3 plus R1. So matrix becomes 1, 2, minus 1, 3, 0, 4 minus 6, minus 2, 0 plus 3, minus 1, minus 9, minus 10. 1 plus 1, 0. 0 plus 2, 2. Minus 2 minus 1, minus 3. And 7 plus 3 is 10. The next is R3 replaced by R3 plus R2, because this is the multiple of this. That is 1, 2, minus 1, 3, 0, minus 2, 3, minus 10, 0, 0, 0, and 0. Next is R2 replaced by minus 1 by 2 R2. This becomes 1, 2, minus 1, 3, 0, 1, minus 3 by 2, and 5, 0, 0, 0. It is echelon form. The first non-zero element is 1. Here 1. Here we have the 1 zeros and here we have the 4 zeros. So the second property is satisfied. This is the 0 rows because it contains all the element are zeros. This is non-zero rows. Again, it is a non-zero rows. So, it is a echelon form. Hence, the rank of the matrix is equal to number of non-zero rows. So how many non-zero rows is 2? That is the rank of the matrix is 2. Now, next example is find the rank of the following matrix by reducing it to echelon form. Again, we use here the elementary transformation to convert in echelon form. Sometimes this form is also called the row echelon form because we apply here elementary row transformation. This R2 replaced by R2 plus 2R1. R3 replaced by R3 minus R1. Matrix become 1, 2, 3, minus 1, 2 plus 2, 0, minus 1 plus 4, 3, minus 3 plus 6, 3, minus 1 minus 2, minus 3, 1 minus 1, 0, 0 minus 2, minus 2, 1 minus 3, minus 2, 1 plus 1, 2, 0, 1, 1, and minus 1. R2 replaced by 1 by 3 R2. That is 1, 2, 3, minus 1, 0, 1, 1, minus 1, 0, minus 2, minus 2, 2, 0, 1, 1, and minus 1. Next operation is R3 replaced by R3 plus 2R2. R4 replaced by R4 minus R2 at 1, 2, 3 minus 1, 0, 1, 1 minus 1, 0, 0, 0, 0, 0, 0, 0. Again, it is echelon form. The first non-zero element in a first row is 1. In the second row, the first non-zero element is 1. So the first condition of the echelon form is satisfied. In the second row, we have the 1, 0. In the third row, we have the 4 zeros. And in the fourth row, again, we have the 4 zeros. So the zeros are in monotonically increasing order. This row is called the zero rows. This is called the zero rows because both are having all the entries are 0. This is the non-zero rows. Again, it is a non-zero rows. So it is a echelon form. It is a echelon form. Hence, rank of the matrix is equal to number of non-zero rows. So we have 2 non-zero rows. So we discuss about the gate problem. The first example is given the matrix A. The rank of the matrix is 4, 3, 2, 1. The options are. This question came in GATE examination 2003 CE. Again here all the multiples of 2. So we apply the first elementary operation is R1 replaced by R3 by 2, 1, 1 by 2, 0, 1 by 2, 6, 3, 4, 7, 4, 2, 1, 3. R2 replaced by R2 minus 6, R1 and R3 replaced by R3 minus 4, R. 1, 1 by 2, 0, 1 by 2, 0, minus 3 and plus 3, 0, 4, 7 minus 6 by 2, 14, 14 minus 6, 4, 0. Here, 2 minus 2, 0, 1. 3 minus 2 is 1. Next is R2 replaced by 1 by 4 R2. That is 1 half 0 half 0 0 1 1 and 0 0 1 1. Next is equation R3 minus R2. That is 1 1 by 2 0 1 by 2 0 0 1 1 and 0 0 0. So it is a echelon form. The first non-zero element is 1. Again here the first non-zero element is 1. The second row having the 2 zeros and the third row having the 4 zeros, which is a 0 rows, lies in the bottom. So it is a echelon form. Hence, the rank of the matrix is equal to number of non-zero rows. So we have 2 non-zero rows. So the option C is correct. Now the one more example, the rank of the matrix is this. The options are 0, 1, 2, 3. This example came into the GATE examination 2006 EC. R2 replaced by R2 minus R1. R3 replaced by R3 minus R1. Get 1, 1, 1, 0, minus 1, minus 1, minus 2, 0, minus 1, 0, 1 minus 1, 0, 0. R2 replaced by minus 1 by 2 R2. That is 1, 1, 1, 0, 1, 1 by 2, 0, 0, 0. Again, it is a echelon form. The first non-zero element in all the rows are unity. The zeros are in increasing order and the 0 rows lies in the bottom. Hence, it is echelon form. Hence, the rank of the matrix is equal to number of non-zero rows, that is 2. The option C is correct for this example. These are the references. Thank you.